Hello there, 7th grade. Welcome to section 626. This is going to be the second to last section of chapter 6 before we move into the closure and then chapter 7. This section we're going to continue on our discussion of solving equations, and we're going to start off with an interesting question where it asks, are all equations solvable? And also, are all solutions a single number? So this sort of guiding question is going to help you see the difference between these two answers, where is it solvable and is the solution only one number? So the question is this. Think about this. Anika was born first and her brother William was born 4 years later. Okay? And then it says, how old will William be when Anika is twice his age? And how old will William be when Anika is exactly his same age? Now, these two questions are very different. So, if William is younger and you want Anika to be twice his age and they're 4 years apart, you can sort of guess and check, well, if he's 1, she's 5. Okay, that's not twice the age. If he's 1, then, or if he's 2, then she's 6. Still not twice the age. And you go over again, you're like, okay, well, let's see. 2 and 6 doesn't work because it's not twice the age. 3 plus 4 is 7, not twice the age. 4 and 8, hey, there we go. So if he's 4, she's 8, that is exactly twice his age. That is one solution to this problem. And then you ask yourself, well, okay, she's 4 years older than him. How old will he be when he catches up to her and they're the same age? And you might be thinking that sounds like a really, really silly question. And you're right, it is. If she's 4 years older than him, they are never going to be the same age. So that is an example of something that doesn't have a solution. So in this first example, Anika's age is William's age plus 4. And in the other one that we were asking is, when will they equal each other? And it's not ever going to be equal, so this is an example of something where you could not tell me that answer, or you could not tell me that age. So when you're solving equations, it's going to happen that sometimes you get a situation where the equations are never going to be equal. And you are also sometimes going to encounter a situation where the answers don't matter what you plug in, and they are always going to be equal. So I want to go over a few of these examples for you. If you are given this equation that says x equals x, and I ask you, tell me a value of x that works for this equation. Tell me an x value that gives you a true answer. And you might say something like, well, what if x equals 3? Okay, that's pretty easy. Does 3 equal 3? Yeah, sure, that checks out. What if x equals 10? Well, yeah, 10 equals 10. That checks out as well. So this situation, any number I plug in is going to give me the correct answer. Any number I plug in is going to work. So this particular equation, right, we're going to just say that any number works for this. Okay? And there's a more formal way to say any number, and we will get to that shortly, but calling that any number for now is fine. Let's look at part B. If I tell you x plus 1 is equal to x, and I say, okay, well, tell me exactly what number makes this true, and you say, well, let's just try something. Let's try x equals 1. Okay, well, let's see. If I plugged it in, it's 1 plus 1 is equal to, let's see, I plugged in 1 for each of those. Well, 1, that's 2 equals 1. Okay, so 1 doesn't work. Let's just try something else. Like, let's try x equals 5. Well, 5 plus 1 is equal to 5. Well, okay, so 5 plus 1 is equal to 5. That's never going to work, right? That says 6 equals 5, and that's not true. So in this case, you have found that is there a number that you can plug in that will make x plus 1 equal to x? Like, even if you try 0, which usually does some weird stuff to equations, 0 plus 1 equals 0, well, 1 equals 0, that's not true. So you've tried a few numbers and you have to think about it. Some number plus 1 equals the number. There are no numbers that works for. So we're going to, again, this is an informal definition, and I'm going to say there are no numbers that work for this. Okay? So you've got two situations, any number or no number. Or you may get to another case where you're like, okay, well, is there a number that works for this, where the number is the same as 2 times the number? Well, if you start guessing and you're like, okay, well, 1 doesn't work, 2 doesn't work, 3 doesn't work, and to go through it, and you're like, well, wait, what about 0? Because like I said, 0 did something weird in this other one. So if I do 0 equals to 2 times 0, well, that's 0 equals 0. That checks out. So this has one number that works for it, specifically x equals to 0. Okay, so there you have 3 distinct situations. You're like, okay, either any number works, or no number works, or one number works. Those are the only 3 things that can happen with these. Then you start trying to figure out, okay, well, what works for this? Let's just say that you were solving this equation, and you're like, okay, well, let's try to solve this and see what happens. My solving steps is to divide it in half. X plus x is equal to 2x equals to 2 plus x. You say, well, let's put the x's on the left because there's more of them. I subtract an x away. I get an x on the left is equal to 2. Well, I have got a definitive x equals 2 answer. Okay. What happens if I had tried that in the first one? If I had said, well, I don't know to put x on the left or right, let's just subtract x from both sides. You might think the sides disappear, but in reality it turns into 0 equals 0, which is, what happens here? If I subtracted x away from both of these in part B, subtract an x, well, that goes away. 1 equals 0, that's weird, because there's a 1 on the left and a 0 on the right. And then here, same sort of thing. You could subtract x. Okay, this is getting kind of like subtract an x, and you're like, well, x minus x is 0 equals 2 minus x. Okay, well, that makes sense because x equals 0 was the answer that worked. So what happens is there are these special cases when you are solving equations. And like I said, there are 3 things that can happen. You can either have any number answers it, no numbers answer it, or a single expression answers it. And we're going to go into the formal definition of this at some point, but what I want to look at is, let's just say you had this expression, 8 plus x plus negative 5 equals negative 4 plus x plus 7, this equation right here. It does say to build the equation on the equation mat with algebra tiles. I would rather you do this with just an expression. So I'm going to rewrite it. Again, I like if you have a positive and a negative together to make that just a negative 5. I've found that it makes it easier to see and work with. So I'm going to rewrite this equation. 8 plus x minus 5 equals negative 4 plus x plus 7. And then you start combining like terms. 8 and negative 5 give me 3 plus x equals, I'm going to combine the negative 4 and the 7 and get 3 plus x again. You may notice that both sides are the exact same, which looks very similar to this any number solution. And so if ever you get the left side is the exact same as the right side, and I mean exactly the same, or it could be x plus 3 as long as they represent the same quantities. If you get the same and the same, then this any number case occurs, and the proper answer to this is that your solutions, it says, are there any solutions to this equation? There are 2 ways to write this. The correct and most correct way that I like to say is to say that the answer is all real numbers. However, you will also see this written as infinite solutions. Okay? And it's a very minor detail between those. However, if it says, what is the solution? You say, all real numbers solve this equation. Don't ask me what the difference between a real and an imaginary number is. You'll learn about that in like 3 years, 2 years. And if it says, how many solutions does it have? The answer is infinite solutions. So that's the distinction between those two. It's very small. The majority of teachers will accept both. I much prefer you to say all real numbers as your solution. Okay. In this next example, well, let's see. We covered one special case, which is every number or all real numbers. So logically, this one's going to be something different. If you have x plus 2 is equal to 2x, we combine like terms on the left to get 2x's plus 2 is equal to 2x's. Now, when you're solving this and you're like, okay, well, I'm going to try to move all of the x's to one side, sometimes what will happen is you're like, well, okay, I subtract 2x. All right, let's subtract 2x's. And, well, you don't just write 2. I've seen people just write 2 for some reason. And you do not just write, you're like, well, everything went away. I only have a 2. I've seen it happen. Just be cautious on this. You do not just have a 2. You have a 2 equals the right side, which is now a 0. And in this example, 2 clearly is not the same as 0. If you think that's the case, then I will give you $0 and you give me $2 and it's going to be the same. And we're going to do that about 50,000 times and I'll take a year off. If you get a situation where it is a not true, like 2 does not equal 0, or 1 equals 0 up there, where you say, oh, this is clearly not true. It says, how many solutions are there? Okay, how many solutions are there? There are none. So the proper way to write this is no solution. Now, again, you may see teachers in the future who give you a different notation for this. Just use what they suggest. I think the most proper answer is no solution because there is no x value that makes that true. Take a minute or two and just try it. Plug in 0, 1, -5, 10. Just try those numbers and you'll find that no matter what you plug in, it gives you something false. So the proper way to write it is no solution. Again, you might see teachers who write like this with a 0 with a slash through it because they picked that up somewhere. Technically that's an empty set, but it's, yeah, don't get into that too much. Just safe answer, you write no solution. Some people will write not solvable, just it's no solution is your answer to it. So what I would like you to do is to practice the answers, or practice the questions on 6-120. So I'll give you a tip on this. So step 1 on some of these problems is going to be a little bit different. Part B, your step 1 is to multiply this 2 into those parentheses. So it's going to be 2x plus 6 on the right side, and then the left side is going to be -3 plus x. So I'd like you to take a few minutes and try to solve this. Like, actually pause the video, get out a piece of paper, try writing them down and solving it. I promise there's value in trying to do that. And then I'll walk through a couple of these in just a second. So I'm going to pretend that you guys paused this video. I don't believe many of you did, but we're going to try. So on this one, if you're trying to solve A, you're like, okay, well, how do I solve that? I want to take the -x and I don't want to deal with a negative. I want to make it positive. So I'm going to add an x value to both sides, which you are allowed to do even though there's no x's on the right side. Like, there's no x's over here, but you can still add it. So I have 2 equals, don't write 4x, it is 4 plus x, and then I subtract 4 in order to get the x by itself, and I get negative 2 equals to x. This equation has exactly one solution, which is good. You like equations that are like that. I want to try part D because it's a little bit weirder, but try the other one, see what you can get. Okay, I'll go ahead and write some of the answers for these. This is part B, the answer is negative 9. Part C, the answer is no solution. For part E, the answer is 2/3. And for part F, the answer is x equals to 0, I do believe. That sounds right. So let's walk through part D. I want you to have actually paused the video and try doing those and see if you can get those solutions. So let's try part D, 3x plus 7. Again, anytime I see a plus minus, I'm going to rewrite it as just a minus x. Plus a negative 2. Again, I see a plus minus. It's a trap. It's waiting to catch you and make a mistake, so I'm going to write minus 2 equals, and then I've got a 2x plus 5. Again, minor changes, but they help. I'm going to combine terms. So 3x and negative x is 2x's. 7 minus 2 is plus 5 equals a 2x plus 5. You have gotten to the point where it is a same expression, so the answer that you write for this is all real numbers. Okay. So I'm going to jump into helping on the homework now. So if you haven't already started the homework, I advise trying it out before watching this part. Okay. 6-122, there's some interesting simplifications that you're going to have to do before you start the problem. And keep in mind that that option of no solution or all real numbers is a possibility here. So you could have all real numbers and you could have no solution. Okay. So you could have none, all real numbers, or one answer. So I want to talk about some of the simplifications that will get you started and then try these out. I will tell you that there's going to be one of each. You will have one problem with all real numbers, one with no solution, so keep that in mind when you're doing this. A good trick to remember is that all real numbers is all the same, so it's same. No solution is not true, or no numbers work because it gave you something not true. So as you simplify this first one, 3 times 4 happens first to get 12. You get 12, and then 2 times 12 is 24. So you're going to start this problem off as 3x plus 24 for that. Okay. On the second one, you're going to start, you could do 7 minus 1 to get 6. And then 3 times 6 is 18. And then continue the problem like that. And on this one, you multiply the 2 through both of those to get 24 plus 2x. On 6-123, it's asking you to show the check step, which is where you plug in that value for x. So I'm plugging in x equals 0 to this expression. And when you go to plug in a number, I always recommend you start with parentheses, even if it's a simple number. It's going to save you a headache in the long run. Plug in 0, and then see if it gives you something true or not true. So then you say if the solution is correct or incorrect. 6-124 is interesting in that it shows you a more complicated way to do the problem, 3 different ways. And it boils down to, if you start this equation off by dividing by 5, you get this horrible, ugly equation with a bunch of fractions. So dividing by 5 at the start, you could totally do that. That's allowed. it's recommended that you don't start with division when you're doing these problems. And then it gives you the other option if you subtracted 34 from both sides. So again, you start with this equation. What if you had done 34 equals 5x minus 21? What if you subtracted 34 and you get this? Is it easier or is it harder? Again, it makes it harder. You just have to figure out why. And then part C is giving you a cleaner, nicer way to do it. So the idea is you add or subtract first to get the x by itself, move everything to the other side. Then the very last step you do is to divide. It makes it easiest. Okay. 6-125, it does say to draw a diagram. I don't care if you draw a diagram because I've shown you how to do this with multiplication. So he puts 20% of his earnings every week into savings. Each week he saves $16. So if you did this with a diagram, which you are totally welcome to do, the idea is that 0 to 100%, and then $0 to whatever his dollars is that he earns every month. And you know that 20% is the same as $16. So there's a few ways to go about this. You could either multiply that by 5, because 20% times 5 is 100. Or you could divide it by 2 to figure out that that's $8 for 10%. And you're like, oh, well, half of that is 10%. Half of 16 is $8. And then how many 10s are there in 100? You just times that by 10. So there's a few different ways to get this. This diagram is actually helpful, even though I suggest not doing that sometimes. The multiplication step is 20% of some number is equal to $16. And if you use the solving tips that we've done, you could have 0.20 as the percentage times x. You could just divide everything by 0.20, which some people have already been doing, at least when we were going over this before, and then you can solve it that way. You'll still get 80. Okay. If he gets a raise that's equal to 15%, figure out the current amount, which is the 100% bar, and then multiply that by 0.15 to figure out how much more he's getting every week. Okay. 6-126 is taking the training wheels off of this factoring topic that we've discussed. You can factor an expression which is essentially unmultiplying a value. So ask yourself, what is the largest number that could go into both of these expressions? So the largest number that goes into 16 and into 4 is 4. So if I pulled a 4 out of that, if I pulled a 4 out to the front and rewrote this as 4 times something, you ask yourself, 4 times what value gives me 16x? Well, I know that it has to have a 4 here, because 4 times 4 is 16. And it has to have an x, because there's an x here. 4 times what value gives me negative 4? The answer is minus 1. So this is going to be a challenge to think in this way to figure out what expression or what value can come out of these. So if I'm looking at 10 and 5, the largest number that goes into them both is 5. And the largest number that goes, or the largest variable that goes into both of those is x for both of those. Because there is an x and then there's an x squared. So if I pull a 5x out of this, you are unmultiplying. And I know that unmultiplying is not a word. It's not the right word. You are factoring it out. 5 times what makes negative 10? X times what is x? There doesn't have to be anything here. 5 times what is 5? We could put a 1 even if we don't need it. X times x is x squared. And then you can just call it an x there. Okay. With this one, you're just going to pull out the largest number that goes into both. Here I would like you to write and solve an equation. I know that you can guess your way through these, but the idea is that x plus 7 plus x totals 13. 2x plus 7 makes 13. Subtract 7. 2x equals to 6. And divide by 2 to find that x is equal to 3. I know that when you have smaller numbers, you could absolutely guess and check your way through this, but writing and solving an expression is a good skill to have. So I hope this video has been helpful to you. If you want the updates when it goes live, I'll say the YouTube thing. You could hit the subscribe, like button, and then you'll get these notifications when they're up. So good luck.